I pass now the word to Mr. Pfauvadel, who is from the French Ministry of Transport in charge of dangerous goods transport, and is also the chairman of the joint meeting at UNECE, Inland Transport Regulation for Dangerous Goods.
Well, we are short in time, so I will not spend much time in saying who I am. Jean-Philippe has already done so. As you may have understood, I am not an expert in computers and intelligent transport services and so forth. So we'll share this presentation with Jean-Philippe. I will just introduce the general part of the presentation, and then Jean-Philippe will talk about the technical issues of what we have done. So this is to report that the use of DATEX-based technology in the context of the transport of dangerous goods. And first, okay, well, you may know or you may not know that the transport of dangerous goods is regulated by international treaties and conventions. And this is something that is already very old now, because the first conventions are started in the beginning of the 19th century. And last but not least, the youngest is, at least in the European countries and zone, is a treaty, an agreement called ADR, who is dealing with transport of dangerous goods by road. And it has been signed in 1957, and after ratification by contracting party, it is applied since 1968. And so now the state of the current state, this is a little bit historical, the current state is that in Europe, plus let's say the wider European zone, including Russia and some other older Russian republics, there are more than 50 countries that are contracting parties, and they are using three conventions, three agreements or regulation. RID that is dealing with railway, ADR that is dealing with road, and ADN that is dealing with inland waterways. And these are actually international conventions. So the principle legally is that they are binding for both the operators and the competent authorities, meaning that operators, when they are transporting or offering anything to transport, need to comply with these conventions. But these conventions are also setting up the conditions under which the different countries are accepting transport. So once these conditions are complied with, competent authorities of one specific contracting party may not require additional measures. Okay, and this is important in relation to discussion about dematerializing transport document, etc., etc. And so the other important thing to know is, although the subject is all this is there is a lot of work going on in technical expert committees to update this regulation, and they are actually updated to technical progress every 2 years. So meaning that the transport conditions, technical building construction for transport engines, but also anything else, like, for instance, the use of new technologies, which is actually what we are going to talk about now. And this, in relation to dematerialization and use of DATEX links, is especially linked to the requirement concerning transport documents or transport information. So in all these regulations, there is the requirement for having what is now, let's say, wrongly called the transport document, because it is more dealing with obligatory information that shall follow the transport, meaning that shall be on board of the vehicle or the train or the ship. And there is an extra chapter that is defining this. And just to give you, when you are dealing with dangerous goods, even the information is something that is complex. And this has, like, for instance, 1 or 2 pages setting up general rules, but then there are at least 10 pages of exception and specific cases, and there are also special rules, etc. So it's really necessary to work, even for an expert that would, for instance, deal with dematerialization of that in that field. It's really necessary to work hand by hand with dangerous goods experts. And of course, this is information that is obligatory to follow the carriage. And the other thing that can be said, not only from the legal point of view, but the transport of dangerous goods is at least one case where having a wrong information can have really life-threatening consequences. Because if you are not declaring a dangerous goods properly, people are not aware about the hazards that are caused, and they are not able to apply the appropriate measures to mitigate the hazard. And so you can, this simple lack of an information, of a very minor, seemingly minor information, can lead to really very severe consequences. The idea of using, so then we have worked on the use of electronic documents, dematerializing this information to facilitate this sending the operation of the operators, but also facilitating the way authorities are able to get this information, getting it more efficiently and more quickly. And there is already something said which is reproduced in this, that the use of electronic data is permitted, but they have to meet the legal requirements as regard to evidential value, etc. And up to now, well, we have done something about that, but there was no real definition of what this. And then the problem is that every competent authority nationally could define the different requirements. So the joint meeting has set up a working group, and it has started quite a long time ago. And this working group, the mandate is reproduced here in the slide, had to look at first what information could be provided by, and at that time we used the word telematics because it was, I don't know, it was kind of neological word, so we used this. What kind of information could be provided to enhance safety and security? What are the necessary parameters for the systems to work around it, and consider also cost-benefit advantages, and what kind of procedures would be necessary in relation to responsibilities, and also consider interface and synergy with existing systems or other systems. And in fact, this work started with the question about dematerializing the information, so the so-called transport document, but it went much further by looking also at possible application for that in terms of safety, meaning, like, for instance, not only the simple fact of getting the information for enforcement, but also organizing, for instance, a better emergency response through things like e-call systems, organizing some kind of, it can go that way, for instance, also how could we use this for traffic management in the future, etc. So all the different possibility of use of this dematerialized information have been looked at. Maybe it's can we get the next slide? And so this, and Jean-Philippe will in the next slide show a little bit more technically the different options and things that have been done. But after some years, the working group ended up in producing guidelines that are now published. Let's say they have a kind of, they are not a regulation, but they have some kind of official recognition by UNECE and OTIF. They are published on their website. Here you have the link for the UNECE website, but they are also published on the OTIF website. OTIF is the International Organization for Railway Transport. And now these guidelines are a way to satisfy in an internationally harmonized way the use of this paragraph that has been shown before, 5402. And the principle is that the competent authority can notify the fact that they are using this guideline, and then they are bound to accept any dematerialized transport document in that form. And operators know that. So they can then operate in a dematerialized way to send their documents internationally in all countries that would have notified these guidelines. And the last thing I shall say before going to the more technical aspects is that we are now also, in the meantime, of course, the discussion about the electronic freight transport information regulation, the FT regulation, is going on, has been adopted at EU level, and it is going on, work going on the implementation of that regulation. And partly we are coordinating with them now, and one part of what we have done here is probably also a way it should be taken on board in some delegated acts for implementing this FT in the context of dangerous goods. Okay? Because in fact, all the specificity of dangerous goods are already taken on board of that. So I think I have now done the general part, and Jean-Philippe will continue with the more technical aspects that I'm not really, he's more competent than I. Thank you.
So thank you, Claude. So I jump to the last part of the presentation. As you see, we began to work with the DATEX II working group very early in 2008. And after that, we concluded an agreement in 2009. And Joseph Calvas, as chairman of DATEX II technical group at the time, made a presentation about the principle of DATEX II. And this principle shows that we have a separation of concerns and already some toolkit to prepare modelization and to make able extensions. And that is what was very interesting for the telematic working group. So they decided to make the first step by defining all the data they need to comply with regulation, which could be put in an electronic form for data exchange. So they have defined that with a table with 3 parts. And you can see on the presentation that they have the formal entry documentation for the transport document. They have part B with miscellaneous information, which like tank certificates, label markings, and so on. And they had, due to the fact that when you introduce telematic or electronic data exchange, some information are very interesting, and that is the part C with the new information, like sensor who can manage alert either on rail with a detector of derailment or on road traffic by alert on fire or axle bearing temperature with detection in case of braking hard. And also that is possible to integrate this kind of information when you have the position of the vehicle. So the position was also part of the data they want to exchange. And that is also a way, and we will see that this afternoon with Galileo and EGNOS. The next slide is the first output of this modeling, thanks to to the methodology of DATEX II that was done by Germany. This was this first document was model was used in a project in France named GeoTransMD, and after in a European project with Italy for cross-border exchange named CORE, we test it, we make some adaptation, we correct some bugs, and we use that to exchange format among authorities and this architecture defined between carrier and authorities and with the coverage of Europe. So I will not go in details. That will be that is part of the guidelines. And then we have a presentation which is the evolution of the regulation is every 2 years, and we managed that last year in summer to address the evolution for the next regulation step. And we were happy to see that thanks to the data modelization and the principle of DATEX II, many things are very easy to manage an evolution in the model and in the data exchange without destroying, if I can say, the already existing exchange. And that was especially the special provision, which are the main evolution of the regulation. And by modeling that as a specialization of a class, that make possible to maintain in place the existing exchanges without impacting people who are not directly tackled by these changes, and only the ones who are impacted by this special provision and evolution will take this information into account, and also the emergency responder and authorities, because they have to take into account all the changes. But for business actor, for carrier, if they are not dealing with the evolution, they have a stable system. And what we learned is also an evolution which was faced with the version 3 of DATEX II, is that we separate also the exchange and the model, and the capability to add some new methods in a web services makes the system strong, because only people who are dealing with these new methods have to evolve their web services, but the other can stay stable. And that is the main lesson we learned. And the deployment is ongoing now in France and in Germany to be used in real world, normally end of this year, with access for authorities.